Morning going? Good? Lovely. Make sure this is working. Oh, yeah. I like to stand. I'm like a big, up and down all the time. Love to stand. Cool, that's information about me. That's where you can find me. I'm James. I'm a developer evangelist at Xamarin. But I always kind of like to open up, not really about myself, but kind of a story of me, but really kind of any developer kind of entering the mobile space. So really got 2 months to develop a brand new iOS, Android, Windows Phone, and Windows Store app to demo at CES in Las Vegas. Now it seems like a little crazy statement, but that was actually my boss telling me that my very first day on the job 3 years ago when I entered mobile. Now, I was a young strapping lad at 25 and said 2 months, 4 apps, no big deal. That sounds like no issue at all. Now before joining this company though, this little startup in Seattle, I'd only built one mobile app my entire life. It was for Windows Phone and Java. Objective-C, I had no idea. Java developers, you just lowercase a few things from C# and you're good to go, right? Objective-C, like back then, like things were happening. There's stars and brackets, and I don't know what's going on. And Android, iOS, I really didn't know. I was a Windows guy all my life. Now, luckily enough, I've been living in Phoenix, Arizona, in the blazing heat for about 6 years, and I had the luxury of being a .NET developer there for about a decade or so. And I made games for the Xbox 360, and that was fun. I said I'm gonna take this awesome career in the video game space, and then I'm gonna go write printer software. Thought that'd be a lot better. So everyone has to write printer software for about 4 years to put software engineer on their LinkedIn page, I think. So it was awesome, but it was a great experience. It was a very large enterprise. It's a very expensive printer. It's very expensive software. But I went to the final PDC in Seattle, Washington, and Microsoft, it was really cool. They were talking a lot about Azure, a lot about Windows Phone. It was the very first time ever that I had this power of a full computer in the palm of my hand. And I could make something on that. A small, awesome experience for users that you get in and out of. And I could do that all in C#. And that was awesome to me. Now, I decided to move my entire life there to become a mobile developer, mostly because I love where I live, which is like right kind of there, like at the base of the Space Needle. It's pretty awesome. But I really moved there for the coffee. In fact, if you follow my adventures probably on Instagram, it's all just coffee shots of London. It's just coffee everywhere. That's all I do is drink you guys' coffee. And anywhere I go, I just love it. In fact, I was late up here because I was like, I have to go downstairs and get coffee just in case. So that's really the reason I moved there, but also because our food is fantastic. And we have ramen, and it just like rains through the streets, and it's amazing. It's really good. But really, I moved there to become a mobile developer, and an awesome opportunity. This company was primarily a hardware company, and they were looking for the first time ever to move into the mobile space. These guys were low-level Linux guys in Vim all day. In fact, I was the only one that was inside of Windows and Visual Studio the entire 2 years that I worked there. It was pretty crazy. But I knew that I needed to find a tool to be able to do this. So the very first day, I got back to my office after my boss told me, I said, if I'm going to find a cross-platform tool or just figure out how I'm going to make these applications, I need 3 things. First is a productive environment. I need to make sure that from day one, I'm off the ground running. I didn't want to learn necessarily new tools if I didn't have to. I wanted to reuse things that I loved, like Visual Studio. I also needed to ensure that if I was going to write these applications in 2 months, and if I was going to write them in a cross-platform way, that the code that I could share would be vast and maintainable and testable. That was also important, because I was the only one that was designing, implementing, debugging, deploying, and supporting. That's mobile. That's how we do it. It's one person, you go. And finally, the company had an amazing reputation for their hardware, and that needed to carry over when we showcased at CES. Really had to impress in the first few minutes. And in my time in mobile, high performance, quick boot time, it makes or breaks your application. So I was a little nervous the first few days, kind of going around and trying to find all these cross-platform tools, and I saw, native this and native that. I didn't really know. And my coworker, Austin, came up to me and said, James, well, do you know about this Mono project thing? And I was like, yeah, I know everything about that. That sounds awesome. I mean, yeah. And he followed Miguel for a long time. I followed Mono. And I pulled up the Xamarin website for the very first time, and I was going through, and I was like, oh, C#, .NET, Visual Studio. I'm like, this is everything that I could dream of. And in fact, once I got started downloading the tools, I found like this was the platform for me. They didn't even need to show me a big fancy logo wall of everyone else that had already chose them as their cross-platform mobile tool. So it was really amazing because I love C#. How many of you are C# developers? Perfect, good choice, I like to say. It's the correct choice. I like to say that C# is the best language, programming language in general. And that's just not opinion, it's fact. So it's just there. You can quote me. I've said it multiple times. If you're not a C# developer, there's amazing things about the language. It has events, lambdas, link support, async await support, all these great modern language features. Statically typed, obviously, so you avoid all these common pitfalls of other programming languages. The amazing community is out there. A lot of development communities have amazing communities, so I don't want to belittle anyone. But the .NET community is vast. We have over 6 million developers around the world. There's tons of amazing libraries and open source projects they could take advantage of. In fact, all of .NET is open source at this point, well, most of it. So, and we have amazing tools. If you've never used Visual Studio, I'm sorry, it's the best IDE out there ever. It's where I started, it's amazing. So what I found is that I could take my love and passion for C# that I've done for a decade, jam it together with Xamarin, and make C# the best programming language for all the applications that I would ever write going forward. It enabled me to get not only code sharing, use Visual Studio and the plugins and tools that I loved, but also create native applications on iOS, Android, and Mac, and Windows all together. So it may sound crazy to be able to take all your C# knowledge and .NET libraries and bring them over, but really Xamarin just embraced and extended .NET the same way that Microsoft created .NET. It's a standard that they created. And if you kind of think of, they had all these great Win32 APIs and they needed to kind of expose them to .NET developers. Well, they kind of just did pinvoke, like platform invocation, right? You can kind of think that Xamarin did kind of the same thing, but they created these C# bindings around every single API in iOS and Android, and then added modern features from the C# library, like async await, link support, events, delegates, lambdas, everything that we know. So as we're writing code, it just makes sense and it's readable because it's just C# .NET code. So here was me, 60 days ago to CES. This was my calendar. I started marking off the days all the way down to CES. And I told my boss, he said, well, what if you were to write the applications multiple times? I said, well, Jeremy, on average, I know that I've done Windows Phone development before, so that'll take me about 5 weeks or so to get off the floor running, build out my shared, my back-end logic here, tie in the user interface, because I'm a master at UI, and I'll just only 1 week, no big deal. About 35 days is my average. And I said, oh, I'll do it again on Windows Store, so another 35 days, and then I'll magically learn Java and all of Android in a weekend, of course. It's easy, no big deal. And then a miracle will happen and I'll learn Objective-C. But really there I'm looking at 140 days, which is nowhere close to 60 days. Well, in the Windows world, in the Microsoft world, if you've lived in that environment, you know the story's a little bit better. Because in general, all of your C# .NET code is already shareable. If you're putting that in shared libraries or portable class libraries, for instance. So you can really think about shrinking that down for just the Windows Phone and Windows Store applications. But again, I'd miraculously have to learn Java and use Eclipse because that was all that was available, and no one's using Eclipse for 35 days and being happy. And then there's Objective-C. So it's 115 days, still nowhere close, not even half the time. But this is what it looked like, actually, when I built out these applications, my first mobile applications on iOS and Android ever. It was 60 full days of C#. The very first time we shipped these applications, I leveraged 70% shared code across the board. All my business logic, my models, my view models, my SQL databases, my RESTful service calls were all shared, all using .NET across all of the applications. And I worked some very long nights. Trust me, these 1 days might have been real 24-hour blocks at some point. But I built out my Windows Phone, Windows Store, Android, and iOS interfaces inside of Visual Studio. So really, I cut my development time in more than half, if you look at it that way. So we were at CES, and my bosses come up to me. Like, we had the apps, we had the new hardware we were demoing to pair with them, and they go, well, we need someone to present these. Now, I had never presented in my life, but my boss, his boss, his boss, and the big boss, because you have to have like 4 or 5 bosses at a company of 15 people, they all turn to me slowly, and they're like, James, I think you're the man for the job. And I'm like a little developer sitting in the corner. And I'm like, okay. But it was a great success. I was really confident. All the applications were out there on all the different platforms, and it was a great hit. Featured on like Engadget and a bunch of other tech blogs. And for me, it was really awesome because it not only just showed that I was able to use my C# skills, and that I chose the right profession, moving over to mobile, because I just loved what I was doing, even though it was an intense 60 days. But also, it was a really great success for the company, being able to beat all of their competitors to the market, because they were just ahead of the curve. It was like remote DVR management, which 4 years ago, like no one was even thinking about. It was really cool. Now, I worked for that company for 2 years. However, I kind of fell so in love with the Xamarin technology that now I work for them. So that's me in 8-bit form. I think it's adorable. There used to be a real picture of me, and I was like, that one's way cuter. So that's the story of me, but I want to give you a little bit more insights into actually how Xamarin works under the hood, if you're curious. Then we're going to do a bunch of demos. We're going to come back. We're going to talk about Xamarin Forms and a bunch of other libraries that we created. But lots of code still to come, so don't worry, it's not a lot of slides. But that's my story, so I want to show you how you can move over into mobile. Now, a lot of people, when they see Xamarin, they hear of Xamarin, all they think about is cross-platform, 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 and C#. Well, actually a lot more than that. We often talk about the Xamarin platform, which is Android, iOS, and of course Windows, all in C#. Now, the intricate part there is it's not 100% cross-platform if you don't want to be. If you're just an Android, you want to make some Android apps? Best platform. iOS, best platform. All the platforms, the best platform, at least in my opinion. And we're using Visual Studio to design, develop, integrate, build, release, test our applications. But we also like to think, well, what happens as you're developing your application? You're going through your release cycles, you're creating your business logic tests. How do you ensure that your applications are performing and functioning and looking correct on all the vast devices in the marketplace? When you look at Android, there's 20,000 different devices. I just shipped my last application, Coffee Filter, which is an app that finds coffee closest to you. I really love coffee. It's kind of gross. And it's really awesome for the fact that when I uploaded it to Google for the very first time, I somehow supported 6,000 different devices. I mean, I don't have 6,000 devices, I have like 10. And that's actually the normal test suite for companies, about 10 devices. But we like to think, well, what about the user interface? How does it shift and look on a tablet when it rotates, when you're going to all these different form factors, all these screen resolutions? Well, we want to enable you to not only create business unit tests for your back-end logic, your portable code, but also your user interface. So we have a library called Xamarin Ui Test, which enables you to write automated user interface scripts all in C#. It's a touch, drag, poke around, all ID based. So it's not coordinate based at all. It's all based on the IDs of the controls. You build out this test suite of not only your back end, but also your front end. And this works on any application. Xamarin, Objective-C, Java, PhoneGap, anything, it doesn't matter. You take those tests and you upload them to our test cloud, which is over in Denmark, where there's thousands of physical iOS and Android devices that you get to log in and use, and actually see your application running on real hardware, which is really amazing. I found so many UI bugs just based on this. Now, we also like to think, what happens after you ship your application? Normally what happens is I get an email that says, this application is the worst application, it crashed, blah, blah, blah. Like, that's the email you get from customers usually. It's usually a lot more vulgar than that. And then you reply, oh, I'm sorry that you're having a bad day. And they're like, oh, you're a real human being. I'm sorry that I was so mean. That's actually the truth. There's so many email threads. But how do we detect and identify bugs and crashes? Well, we wanted an easy way for .NET developers to have one library in their portable class library, in their shared code, for all of their applications. And that's Xamarin Insights. It's not only Crashalytics, but also analytics as well. So with one line of code, you get managed and native crash reporting for all of your applications, iOS, Android, Mac, Windows Phone, Windows Store, and even WPF or WinForms desktop, whatever you're doing. One library, one API. Now, of course, there's tons of great content from Xamarin, videos and documents and developer docs, everything. We also have Xamarin University, which is live interactive training with real live interactive Xamarin University professors. That's the only way to get our Xamarin certification. So if you're like a consultant and you want to get certified, that's the way to do it. So maybe you know nothing about mobile, or just looking to revamp, or know nothing about Xamarin. You can go from knowing absolutely nothing to being a full Xamarin certified developer. It's full year-round, 24 hours a day, 6 days a week. So I think they take Sundays off. So that's Xamarin in a nutshell. But when I started, I like to think, well, what is native? What is a native application in general? So my boss told me, well, we need a native application. I said, okay, that sounds great. And I went to all these websites and did a bunch of POCs. I said, well, how can something be native if it's just running in a web browser? That doesn't feel native. It doesn't look native at all. So over the last few years, I've really developed 3 important aspects to being a native application. First is a native user interface. You want to ensure that to your users, there's a reason, they bought an iOS device or an Android device or a Windows Phone device. They like the look and feel of the hardware, but also the software. So we want to be able to use the native widgets, the native libraries that are coming out, and give them a great native look and feel to their application. So when they open that Android app for the first time, it doesn't look and theme like an iOS application or a Windows Phone application. It looks like an Android application. That's what it is. Why hide the fact? Don't hide it. It's beautiful, I swear. And then, of course, all of the APIs. So there's tons of SDKs and APIs available for iOS and Android, and of course Windows. So as developers, we want everything. Why would we want a subset of all that? And then, of course, I've talked about performance before. I'll talk about performance again. Really, when you think about it, the first time I was actually on the tube last night, this is a true fact, this is a true story. I was on the tube last night coming home from Shoreditch. Did I say that correct? Like Hipster Central, I love it. Awesome food. I was coming back on the tube and I saw a gentleman on his phone launch the application, goes on the splash screen, 1 second, 2 seconds, 3 seconds, loading some data, home button, done. He gave it 7 seconds. That's all he gave his application and he was done with it. Like that's what we're talking about. Like your app has to be fast, bootable, quick. Like that happened. I was like, yep, and it made sense to me. Because I've been doing this for so long, it has to be instantaneous. It's really important. I can't even tell you how many times I've installed an application, looked around, poked around, it didn't feel great, I just uninstall. What did I give it? 30 seconds, 60 seconds? And that developer works a long time on it. I feel bad, but not that bad. But that's the thing, is you have to make your app stand out in the marketplace, but also as developers, we want to get to market fast, but we need to ensure that we're not losing these qualities. So there's a lot of ways to get there. Often a lot of companies are doing this today, which is the silo approach, and this is what I could have done, which is building out an iOS application in Objective-C, Android and Java, and of course the beautiful world of C# and Visual Studio for all my Windows apps. And of course I could use Xcode, Eclipse, or Android Studio, but what's the problem here is that if you're a small 1 or 2 man shop, how do you manage all that code? How do you manage your source control analysis, your actual unit testing, your UI testing if you're going to do it? And as you get larger, and maybe you start only on iOS and you want to bring it over to Android. So now I got to learn all of the SDKs, all of the APIs again, all of the UI again, and now I'm not sharing any code at all. So I got to do the entire application from scratch. And when I come over to Windows, I got to do it all again. It gets really expensive really fast, and different tools. So of course, wouldn't it be great if you just write all that code and put it there once? That's what we like to call the write once, run anywhere approach. Often a lot of HTML and JavaScript and CSS going in here. The problem that I've talked about before is it's not native UI, not native performance, never will be, can't be, it's a web browser. And then of course you're developing against that lowest common denominator, so a subset of the APIs available on each platform. So they have to give you something common across the board. So it's kind of the lowest common denominator. So I like to say you're developing against their API, not the API of the platform. And for me that's problematic. So that's where the Xamarin approach is drastically different, and how it works under the hood is magical and lovely. But we enable you to take all of your .NET code, nearly all of your .NET code, I would say, and build a shared C# backend. Now, these are libraries that maybe you pull down from Nuget as well to incorporate into your shared code, like JSON.NET, Azure Mobile Services, a plethora of other ones, service stack text, like anything that's .NET related, C# code runs and works. So these, obviously in my application, are my models, my view models, my SQLite databases, RESTful service calls, any of those libraries that I'm using in the .NET world, platform independent code. Because most applications are doing the same thing, pulling down data, displaying in a user interface, and letting you tap around to go to the next page. So that common code, the things that the applications do commonly, are in that shared C# backend. One library, maintainable, testable. Then we give you the tools on iOS, Android, and Windows, of course, to build out and architect your user interface, so it says UI in there, but also take advantage of the platform-specific APIs. So if you want to do anything platform-specific, those are where those libraries live. So if that seems like magical rainbows and unicorns, it's not. Like I said, I've already told you exactly how it works, but this is kind of what it looks like. I've been a Windows developer forever, so I had all of the .NET libraries on the bottom here available to me. Then when I went to like Windows Phone or WPF or Windows Store, I had just a new SDK and APIs to download. So now I can take advantage of not only SystemNet, SystemLink, XML, but now I have storage and networking and all the Windows Phone or Windows Store specific APIs. So of course, now as a .NET developer, when you move over to iOS, you have exactly the same libraries on the bottom, all that .NET goodness, powered by Mono and Mono, the original open source implementation of .NET, all running there, shareable, and then you get new APIs and SDKs to play around with, like UIKit and iBeacons and Core Graphics, all available to you, because those are the native APIs, all in C# though, so you never have to touch Objective-C or Java. We do have a way to bring that code over though, and bind it up into C#. And then of course, same thing on Android, just different APIs. So you have Action Bar and Printing Framework and NFCs, things that are specific to Android. So that really means that anything you can do in Objective-C, Java, or Swift, you can do it in C# in Visual Studio. We're able to leverage native performance. Like I said, we're the maintainers and creators of the Mono project, which is the original open source implementation of .NET. Miguel de Icaza is our CTO. How many of you are familiar with Miguel at all? A few. I wasn't when I started, so don't worry. And now I present with him like on stage. It's crazy. So Miguel's been in the game for a long time. He created the GNOME a long time. I think he calls it GNOME. I think that's how you actually say it, but I'm going to call it GNOME. He was big in the Linux days, and the original idea of Mono was running .NET on a Linux server. So through multiple ways, Mono and the Mono runtime found its way to iOS and Android, powered by us at Xamarin. So what we do over here on iOS is we do a full ahead of time compilation of the Mono runtime. Just think of the Mono runtime as just another .NET runtime, except for it works on the phone, or on Mac, or on Linux. So we do a full ahead of time compilation of all your C# code, compile it down into IL and then into LLVM bytecode. That LLVM bytecode goes through the same compiler and optimizer that Objective-C and Swift applications go to. So at the end of the day, your application runs natively as an ARM binary. It just runs, all garbage collected for you. It's a magical world. Over on Android, it's interesting, because Android, interesting, works completely different. It's almost very much Windows-based, right? It's kind of like it's VM-based. So every application spins up in its own little VM, which of course hurts start time, but that's Android. But we're able to leverage just-in-time compilation to actually run the Mono runtime side by side the Dalvik or Art runtime that's already there. So your .NET code runs over here in the Mono runtime, which is often, if not always, faster than the Art and Dalvik runtime, because they're just not great runtimes. And then we're able to JNI across whenever we have to do Android calls, specifically, and we manage everything for you. But in either way, to your users, it's just an Android or iOS application that they've installed from the App Store. There's nothing different. There's no additional downloads. There's nothing crazy special about it. It's just an app that they've downloaded. If you've done it right, you're not, created a good app. Anyone can block the UI thread way too much and crash an app, but I've done it. To your users, it's just an application. And when I started, I was always worried, well, what happens when new versions of iOS, new versions of Android? I'm an Android guy. It's my favorite platform. It's crazy and complex for no reason, but I love it because you can do anything in it, and all the source code is open source, so if you really want to see what's going on, it's there. But I was worried about how these platforms are moving so fast. How does the tooling keep up with it? How do we get the new access to the APIs? Well, as Xamarin, we've been offering same-day support for iOS since iOS 5. The company's only 4 years old, so that's a pretty good track record. And then additionally, it's not just that, it's all these new emerging devices that I can take my code. So things like Google Glass, Fire TV, Android Wear, Apple Watch. We have full support for all of these APIs and SDKs out there. In fact, we just shipped same-day support for Apple Watch, the same day that Apple had their big conference and announced the final version of the SDK for Xcode. So from day one, you can get up and running and you're good to go. Now you might notice there's no Android same-day support type of thing up there. Android's a little bit different. Google just goes, here you go, here's a new version. The same day that Apple did the Apple Watch announcement, like no one knew, but Google's like, Android 5.1, here you guys go, have fun. Like they did a whole bunch of new libraries for like no reason. We were able to get most of that stuff done in just a few days. Android's a little bit different. Sometimes it's big releases, sometimes it's small releases. So we always get an early alpha and usually just a week or two, the final stable, a month or two out there. The difference here and why this is so important, why that may seem bad, like James, oh my goodness, like 2 months. Well, within 2 weeks of release of iOS 8, 60 to 70% of all users had upgraded to the latest platform. So you need to be there ready day one. Now we just didn't offer same-day support. We offered early alphas from the beginning, just like Objective-C and Swift developers had as well. So you already had your application ready to ship. When iOS 8 shipped, I shipped my app same day to the App Store. It's for the update. Android's a little bit different. You know, Lollipop's been out for what, nearly a year now? I think it's at about 4% of the market worldwide. So while it's great to play around with the new toys, not necessarily 100% important. What's important in Android are all these support libraries. They have these backwards compatibility libraries. And we get those to you within a few days or a week. And that's the important stuff. So let's build an app. That's enough slides for now. Let's just go ahead and actually mess around with it and actually build out some applications. So we have multiple IDEs. So when you install Xamarin for the very first time, when you go to Xamarin.com, sign up for a trial. We have a full 30-day trial of everything. So everything you can see here, you can do on the trial. We have 2 IDEs. We have Xamarin Studio, which is this puppy right here. It's available on Mac or PC. On the Mac, it does iOS, Android development, kind of anything that you can think of. And you have a nice dashboard. It looks like an IDE. I love it, especially for iOS development, because everything is self-contained. So when you install Xamarin for the first time, for iOS development, you install Xamarin, and then you have to install Xcode, and you have to have a Mac to do iOS development. There's no way to get around it. Apple requires it. It's in the EULA. I could send you the direct line from the EULA that tells you that. It's very unfortunate, but you have to have one. Now, you don't have to have a super fancy MacBook Pro with 16 gigs of RAM. I recommend it. It's pretty nice. But you don't have to. In fact, all of my iOS work that I did at the startup was on an original MacBook Air with 4 gigs of RAM and a 1.6 dual-core processor. So you don't need a beast of a machine. So inside of here, you have everything you kind of think of. You can do new solution, pull up an iOS application. Like I'll just create something here, DevWeek, day 2. It looks like an IDE. It feels like an IDE. We have built-in source code analysis as well, which is really nice. So this is just one of the options. So a normal iOS application here consists of a main storyboard. A main storyboard is an entire overview of your application. It's all the screens of your application. We have a designer built right into Xamarin Studio. I'm going to do just a little work in Xamarin Studio, and I'm going to switch over fully to Visual Studio. How many of you are Visual Studio developers? Yeah, exactly. Me too, don't worry. The nice thing is we treat each IDE as a first-class citizen. So when features are shipped, they're usually shipped across the board. Sometimes Xamarin Studio gets some things a little bit earlier, just because on iOS land it makes a little bit more sense, like WatchKit previews, for instance. But here we go. So here's my first storyboard. What do you know? I have a full toolbox available for me. I could add a button in here. These are the native actual iOS buttons. Could go ahead and mess around with things. We have full support for all the bits, I should say, all the things that you can do inside of iOS. How many of you have done iOS development before? Anyone? A few of you? How about Windows Form development? Perfect. You guys are already ahead of the curve. It's exactly the same. iOS, Windows Forms, it's 100% the same. That's how I feel, at least. Because look, you got a label, and you drag it on here, and you're like, ooh, I got a label, and I can make it bigger. You can add constraints on it, and you're good to go. We have auto layout support, constraint layout, everything you can think of. There's a button here. We can name this button hello. We'll take our label over here, and if we look down at our properties, I'll zoom in over here, all fancy. There's a name, so I could say label hello. There we go. Now what that does under the hood, which is really cool, is our tooling handles a lot of the intricate parts of how iOS works. So in Xcode, you actually have to drag these lines around to different files, but when you name a control something, we just create that property for you under the hood. And you can see what the designer is doing here. It's actually creating these things called outlets. automatically. So there's an outlet there. Let's go ahead and change the text here, and we'll say click me. There we go. Now, additionally, we have all these events. So we put the events over in the events properties page, and there's a lot of different click events over in iOS land. So touch down, repeat, touch up inside, touch up outside, touch cancel. We're going to use touch up inside. That means I touched down and then I touched up and I was still inside of the control. But of course I could add the handler there, or I could just double click on it and then add the event handler. So there it is. Handle that for you automatically. So there we go. Now we could do a few things. I could do your traditional, int count equals 0. Like, oh my goodness, count plus plus, and then I could just simply do like a label hello.text and say, string.format, hello DevWeek, we clicked this many times, best demo ever, hashtag best demo ever. That's cool. And then we'll pass in the count. Lovely. There we go. And now I could run this, and we have all the different simulators that are available here on iOS. But this is just some code. Now, if I want to do something really complex, we can see already that I already have my system core, Xamarin iOS, and this is where all the native controls and libraries live. And I could always come here and say Edit References. So you can see it looks very much like Visual Studio. We follow the paradigms very close. But we have all of the system, the mono, and also system.net implementation. So here's system.net HTTP. I could add IO compression, system data, system link XML. So if I'm using these things, I can bring those in. Additionally here, if I wanted to, I could come up to my top project and say, hey, I want to add some Nuget packages in here. And Nuget's always super speedy, even on a wire. So I can say, oh, I want JSON.net. Cool, let me add that package. Now I have JSON.net to do some JSON deserialization. That's pretty awesome. There we go. Now, in this case, so I have some other packages in there. I could do a bunch of stuff with it, and that's what we'll do later. So kind of give you some preface of the tooling. If you use Visual Studio, that looks pretty familiar. Did some editing, did some Nuget support. Wow, JSON.net just adds it, and that's great. So it has support for Xamarin. So let's run this and see what it looks like, not having done anything with those awesome libraries that I just added. So this simulator should be absolutely, oh, it's not too bad. Nice and big, there we go. We can click, 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 click. And what do you know, it totally works. If I come in, I put some breakpoints in here. Click again, get my watches, my locals, everything, just like you would in Visual Studio. In fact, if you want to get a little bit crazier with this, let's actually prove that a lot of this .NET-y stuff types works. So let me come back to my storyboard, and I'll add a few other properties. So let's add like an activity indicator, so a little spinner. Let's just put this down here, and let's go ahead and put in a text view, something longer. Pull this out. There we go. So we'll come up here and we'll say this is going to be my progress bar. There we go. This guy here will be our text view details. There we go. So we just added a few more properties. So we've added HTTP client. So now we could actually take advantage of that. So if we come over here, we say, well, let's go ahead and do a few things. I'm going to come into this method. I'll say my progress bar dot start animating. So I'll start animating it, spinning it up. I'll say progress bar dot stop animating. Be a little bit nicer here, and we'll say button hello dot enabled equals false. Button hello dot enabled equals true. That's good. So kind of do a little state here, do stuff. There we go. And we'll come back here and we'll maybe pop up a new alert dialog. We'll say a new alert, UI alert view. There we go. And we're going to pass in some stuff so it'll pop up a little, hello, hi DevWeek. Oops. Hi DevWeek. Boom. There we go. And then we could, we don't really need anything in here for these. We'll say OK. And There we go, alert.show. There we go. So pulling up a little native alert dialog box. A few lines of code just to do that. So let's do stuff. Let's take advantage of our client. We'll do a new HTTP client. There we go. Go ahead and resolve our namespace out there. Now what we want to do is, this will be like the worst but best demo ever, just to kind of show you how we add and mix in the .NET-y part of things with the actual iOS APIs. Because obviously this UI alert view, that's an iOS API. Animating progress, the native UI spinners, all native. But HTTP client, that's not native to iOS. They have their own crazy network stack to deal with. But HTTP client is our native stack. It's pretty much awesome. And I can go, client dot, get string asynchronously. We can pull down maybe my blog, Mott's codes. There we go. Fancy .es domain name. And this will be my website. And what we can see here is that this is actually returning a system. Let me go get this over. This is returning a system threading task, and it's going to return a string asynchronously. How many people are not familiar with Async Await? You guys all are. Awesome. When I said that like 4 years ago or 3 years ago, like everyone's hand went up. It took me forever to wrap my head around it. But it's amazing because I can go ahead and just mark this as await. And I'll mark this entire method as async. Async void bad, but we're in a click handler, so I'll say it's okay. And then what we'll say is text view details.text, and we'll set that equal to our website. That's pretty cool. But let's get a little bit more crazy with it. Let's go ahead and do something like a UI view.animate. Let's animate a view asynchronously. So let's go ahead and over 1 second, let's go ahead and say, text view details.alpha. Let's set that to 0. There we go. We'll wait on that. And then when I'm all done, before I stop animating here, we'll await on UI view, which is a native animate asynchronously over 1. We'll go ahead and say text view or text view details.alpha. We'll set that equal to 1. Make sure it's a float, I guess, just in case. So what's interesting here, if I actually pull up the UI view and what I'm doing here, UI view, and we see we have animate, where's animate? Animate and animate async. So this is the part where I'm talking about is we're adding the async await to a native API. Traditionally, if I go through here, if I came over, whoop, different desktop, where'd it go? There we go, whoa, crazy. If I actually looked at the animate API, we can see that normally it takes in like a callback block of duration, animation, and complete to do something afterwards. And that would be tedious for us to actually have to manage callbacks over and over again. So we use our good friend async await. We'll animate that view out. We'll go get that string, display it in there. And if all this code works and the internet works, this should just work, and this will be awesome. And this nice thing is I go off on the background thread, do a bunch of work with the HTTP client, come right back onto my UI thread, click, get rid of that breakpoint. Boom. There's a whole bunch of stuff that just happened in like 10 lines of code. So in that instance now I could do something with this XML. This isn't my entire website, obviously. That's not a great user experience. Maybe not the most beautiful application ever built, but it's pretty sweet. Ship that right to the store. Apple will approve it, I'm sure. They love rejecting every app, so it'll be one for them to add a tick on. So that's it, but that's how you are combining all this code together. Now what's really cool is that all of this code, this asynchronous code, now at this point I would probably get some JSON back, deserialize it right, put it in some data models. All that code now could be brought into a shared portable class library and shared with an Android code. So let's actually build out a real application, and we'll go over to Visual Studio. So I'm going to pull up, and I'll tell you about this whole setup here. So obviously I'm on a Mac. I have VMware. You can use Parallels or whatever other VM hyper virtualization you want to use. So the reason I'm here inside of a VMware is obviously because that's where Visual Studio lives. So we can pull up a new IDE. Now, to be able to do iOS specific work, like I said, you have to have a Mac. The wonderful world of Android is that you can have just a Mac, just a PC, it doesn't matter. All the SDKs, all the tooling are just there for you. Obviously with Apple, it's a little bit different because only the SDK and tools and compilers and optimizers are on that platform. And we don't cross-compile at all. We have a special compiler and optimizer for Android, one for Mac, one for iOS. So we don't cross-compile anything at all. So that's why here on iOS, if I do a new iOS project, on this side of things, so here's iOS and iPhone, do another single view application. I have to run, now, when I say that the actual, that you have to have a physical Mac, all of this doesn't have to be on the same physical Mac. You could have a full dedicated PC, but the intricate part is that when you install Xamarin on the Mac, we also install this little application called the Xamarin Build Host. Its sole duty in life is to connect to Visual Studio and do remote compilation and debug sessions for iOS. So that's what sits right there. So now over in Visual Studio, we have some integrations into the toolbar up here. We can see that I'm connected. I can disconnect. I can manually refresh that connection up there. So there's just a toolbar. We can also see we have my Android toolbar over here as well. So there we go. And I could disconnect this here and then reconnect to show you what it looks like for the very first time. This dialog pops up, says, hey, you got to run this build host. It uses some Bonjour services to go out, find anything on your network. So it could be like a little Mac Mini, which is a few $100 US to pick up. And then it'll connect to it, and it'll do everything remote. The intriguing part there, though, is that when you go to debug your application, it's going to run over in the iOS simulator or iOS device plugged into your Mac. So you can remote desktop into your Mac and mess around with it that way, but your simulator doesn't magically work on iOS or on the Windows part side of things. But what's nice here is when you go to debug, if you're on a Mac, it just pops up right on top. So this environment is pretty much preferred but not required. So you don't have to buy new tools if you don't want to. All right, so let's actually build and open a new application. So when you go to Visual Studio for the first time, you'll see we have Android templates. So there's all these different Android things in here, all the iOS projects. I'm going to go ahead and open up an existing project, and we're going to build it out here. So it's called DevWeek Tweets. So this application, I already have kind of I've set up and I did file, new project iOS, file, new project Android, and file, new project Windows Phone. Additionally here, I've already added my shared code project. So you can share code with Xamarin in a few different ways with portable class libraries, which are one DLL that are shipped and maintainable that just work on different platforms. So that's what I have here. That's how I like to structure. There's not a lot of code in this application, but I have my models here. And I also have my view model, so we can open that up. So we can see this application could get a lot larger. But let's go ahead and I'm going to stop hitting that button. So my tweet, for instance, has like some text, a status ID, a screen name, a date in here, a created at, some other time that's coming in. Then my tweet view model, so I've architected this in an MVVM type of way. So model view model, it's like MVC, but with more V's and more M's. It's all it is, I swear, it's all it is. It's that simple. Architecture, it's that simple. That's what I told my architect, and he said, okay. So we have an observable collection of tweets that's gonna get loaded, and I have this load tweets command that's in here, and it takes in a string to search, so you can search whatever you want. These are all my cool, awesome keys that I put on GitHub, so I don't even care anymore, and you can pull down this code. And this is using a library called Link to Twitter. It's pretty much amazing. It leverages the power of reactive extensions to do like reactive, like asynchronous craziness, and link to allow you to query Twitter. Like in this one select statement, I'm searching Twitter with a search query and give me the first one all asynchronously. Like give me the first 100 results, just give them to me. And it'll select this tweet. And then what I'm doing is I'm parsing his statuses over here again with a link statement, a select statement to actually just parse those into my data objects here. So that's what I'm doing there. So pretty straightforward. So this portable class library here, if I open it up, we can see that it's already compatible with Windows Phone, Silverlight, Android, iOS in here as well. Well, I didn't check Windows Phone 8.1 or Silverlight just because I didn't need them in this instance. But you can go in and toggle these different versions if you want to. So that's what a portable class library looks like. It's one project, all your code goes in there. Now, the more checkboxes you check, the smaller the subset of .NET that you can use. So for instance, the idea here is it's platform-independent .NET code, but not all of .NET is everywhere. We fall directly into the .NET 4.5 profile, so we have tons more APIs than phone. But what's nice is that with the power of Nuget, if I go over here, we can actually see that it brings in all of these great libraries that you can use. So I'm using like SystemNet, HTTP, IO compression, things that didn't exist in that profile that Microsoft calls it. So you can always add functionality because it's just .NET, which is pretty cool. So now we can leverage this and we can build out an iOS application. So let's start there and then we'll build out our Android application and share all the code. So here's what I'm going to do. I'm going to pull up the Storyboard Designer here inside of Visual Studio. We'll pull out our properties and our toolbox here. Get this down so we get a little bit bigger designer here. It'll think. It's a nice, beautiful spinner. I wish we had something more animated, like a little monkey like swinging around or something. It's our mascot, so it doesn't make any sense. All right. Here we go. I have a navigation controller. I have my DevWeek tweets here. And I can just go ahead and start dragging some stuff down. So let me do like a text field. Drag that down in there. Pull this around. We'll add a button in there. There we go. And we'll call this button get tweets. There we go. And we'll name this to get. Down in here, we'll call this text field search. Sounds pretty good. And by default, we'll put DevWeek. What's the official 2015? Maybe just DevWeek. We'll go with DevWeek. That sounds good. So that's going to be the default there. And then we need some way to display a list of results. So let's add a table view in here. So there's our table view. There's our table view. Put that in there. Make it a little bit bigger. That's looking pretty good. Now we can call this our table view tweets. There we go. And then we can start designing our actual cells that are in here. So each cell you can design separately or use some of the pre-baked ones that come in there. So here I'll go ahead and just say that this is going to be a subtitle. So you get like a little live preview. I could look at the other built-in ones here. I could go ahead and see those come up in real time. That's going to be my subtitle. And we'll make the selection like gray perhaps, and the cell reuse, so when we're reusing our cells, iOS handles that for us automatically. So that's a tweet in there. Looks pretty good. And we're basically halfway there. We'll add our little click handler. Let's make this a little bit bigger, why not? There we go. We'll just go ahead and double click on this again, add our touch handler there. All right, perfect. So back in my code behind, I've done a few things. I've added a little activity indicator, a little spinner. I put that in the navigation bar. It's a little bit tedious code to write, but it looks really cool, so I added it. Just make a little activity indicator spinner, and I shove it in the toolbar up there, which is kind of nice. So what we'll do here is we'll first say we'll use that activity indicator, and we'll say start animating like we saw before. We'll say activity indicator.stop animating. Now, what I've also done is I've created my Twitter view model. So if I look at my Solution Explorer here, and I pull up my resources, what we can see is that I'm still referencing all those Nuget packages, like link to Twitter and net HTTP and all the other extensions that are required. But I'm also leveraging and pulling in my portable class library, so all that shared code. So that would obviously grow a lot over time. That's where you're going to put everything. So I have my view model here. And what I'm going to do is I'm going to say viewModel.get load tweets command. We'll pass in the search, so text field search.text, and we'll trim that for good measure, just to be sure. Additionally, I know that I need to do one thing, which is text field search.resign first responder to make sure the keyboard goes away. That's very iOS specific-y. So we're going to await on this. I marked this as async. There we go. Await on it. And now at this point, we have our table view tweets, and we'll tell it to reload the data that's in there. Boom. So we get the data, tell it to reload the data. Now we just need to tell our table view how to display the data. So we do that by coming up here. And I should preface that, what did I just do? Like, where does this code all live? Well, every single page inside that Storyboard Designer has some code behind to it, kind of just like a page in XAML. Well, this is a UI view controller. So a UI view controller is a single page, the code behind linked directly to that page that we saw on the storyboard. That gets loaded in a magical world that gets routed through a main.cs, because you have to have a main with some string args. And all that does is start our app delegate, which is our full application cycle. And inside of here, you can do some initialization. You get calls when you enter the background, enter the foreground. And this handles launching the storyboard for you automatically. So here, for instance, it now will load this root view controller. Here's my code behind. And you can push and pop with the navigation stack with UI view controllers. So that's a little what we're doing in here. So let's go ahead up here and let's actually tell this UI view controller that we can actually handle some functionality and tell our table view how to inflate those controls. So I'm going to say UI table view data source, which is an interface here. I'll go ahead and implement that. So our interface here has two methods I need to fill out. I have a get cell and a get row or rows in section. Because in the table view you can group things together. We're not doing that, so I'll simply return my view model .tweets.count in there. There we go. Now we can go ahead and get our cell. So here's our cell. And what's really cool is that our table view can actually dequeue a reusable cell automatically for me with an identifier. So we marked that a tweet was the actual identifier earlier. And we'll return that cell at some point. It'll create it for us automatically if it hasn't been created, so we don't have to worry about that. So now we can grab our tweet, say view model .tweets, and we'll index into it. And this method gets past this NS index path, which enables you to see what row or section you're in. So what we're going to do here is we're going to use the index path .row to get currently what it wants to display. Now we can go ahead and have our cell here. Here's our cell. We'll say text label. So there's a main label and a details label .text. We'll say tweet. Let's put the display name in there. We'll say cell .detail text tweet .text. And we're basically done at this point. Let's go ahead and clean and rebuild it up. So here you can see we integrate right into the debug menu. So here's the iPhone 5 simulator. Let's go ahead and start this here. So this is going to talk to that build host directly, and it basically is shipping the code. So the first time I ship the code over, it's going to take a little bit longer to build up and compile, and then it can actually do iterative builds and compilations. So here's my application. I've spiced it up a little bit ahead of time. I can say get. Here's my little spinner. And ideally, if there are any tweets, there can't be not any tweets. Ah, there's no data in here. That's cool. There's one thing I need left to do that I forgot to put in. So our UI view controller knows about the data source, but our table view isn't smart enough to say, hey, your data source is this guy here. So what we have to do here is we have to say table view, and our view did load, so before it actually is visible, .weak data source equals this. Boom. We totally had data, just didn't know how to display it. So let's go ahead and ship this again. There we go. There's all the tweets. As you can see, if people are doing this correctly, you are live tweeting, and then you can actually validate that this is actually totally working. It's the fun part of live demos. So there's that, but we can spice it up a little bit more from here. Maybe we want to add some images, because Twitter has images in there, but all this code is here. We can see it's all reactive as I want. So what we can do is we could use Nuget, or we also have this thing called the Xamarin Component Store. The Xamarin Component Store is a hand-curated list of components and libraries and controls that work specifically on iOS, Android, and Windows. So Nuget's like the Wild West almost. It's just like anyone can publish anything. It doesn't matter if it's tested or not. But these components go through a certification process. Someone actually goes through the samples, tests them, makes sure that they work on each platform. Some are free, some are paid. Most of them are free, about 95% are free. But you have things in here like SAP, Azure Mobile Services, SQL Cipher, which is a 256-bit AES encryption database, a bunch of other stuff in here. And when I type in image, there's a few different imaging libraries, and I'm using this one, this SD web image. So I've already added it to the application in here, but it automatically downloads and caches images for me automatically. So if I go ahead and double tap on this here, we can see that there's a whole getting started, there's samples, you can see what assemblies or packages have been loaded up automatically and open those. So we're just gonna steal this code here automatically. It even supports animated GIFs, that's new, that's awesome. So we're gonna go down to our cell, post this code in, and get rid of a few things. So get rid of that. We're gonna tell it to set the image, and we'll say this is gonna be my tweet.image. There we go. So now with that one line of code and that library brought in, this should automatically handle all of the image downloading and caching for me when we load this next. There we go. So as we scroll through, it starts downloading images, caching that all up for me automatically, which is pretty cool. Just a few lines of code. I don't have to worry about that code. I can go and figure out how that's working if I want to implement it later on, but it's all done for me automatically. It's nice, smooth performance because I'm doing all that cell reuse automatically. Now, of course, it's a simulator, so it's using it's using all of the RAM that I can possibly give it. So of course it's smooth, but it's pretty good. So let's do this on Android. So on Android now, I already have the Android application built. All I did was file new project. So over here I have my Android project. If I go ahead and pull down the references, this is gonna look very, very similar. I have all my references in here, I have a bunch of support libraries, some image caching already in here, and obviously mono.android, which is all the Android libraries, and my portable logic in there as well. So similar, let's go ahead and close out all of this. Has anyone done Android development before? A few of you? So we follow the same exact naming and resources and everything like that in Android land. So for instance, over here we have our resources. We have drawable, layouts, and values. These are where all my images and assets are going. My layouts are an XML representation. I like to say it's just like XAML, but not at all. And you'll see why. This is why I fell in love with Android. I was a XAML guy. I found XAML, I was like, this makes complete sense. And then Android was just like that, but just not very good. But I could understand it because it was all XML, and that was cool. Then we have values in here. So anything that you were doing, in fact, if you had an existing Android application, you could just pull over your resources automatically. Same thing in iOS. You could pull over an existing storyboard file, and it would just work, which is kind of cool. So here's all the different files in here. And I have this main Android XML file. And we have our Android Designer built right into Visual Studio, also in Xamarin Studio as well. So just like we kind of saw earlier, I can pull out my toolbox. I have all the different properties and controls available to me here. This will go ahead and load up here. It's a beautiful blank page. But we can go in here and we can add a, let's see, text. Let's go ahead and add a plain text view. That looks good. We can add a button. There's a button. And then we'll add something called a list view here. There's our list view. Boop. Cool. So we can see automatically that it's, we can zoom in here, what it looks like. We have an edit text up here that will type in something. We have a button and a list view that will be propagating up with all this stuff. Now you can see what this looks like automatically with landscape mode, different versions of Android inside of here, different devices, screen sizes. We have support for different alternative layouts for landscape versus portrait. So anything you can think of. And what this is doing under the hood is creating that Android XML for you. So this is Android XML. It looks just like XAML, but it's Android, 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 Android. I wanted to let you know that that was Android related. In the XMLNS, it's going to look very familiar. It's just a schema, right? And we have different Android properties. But the difference here is there's no data binding to any code behind. So it's not like XAML in that aspect. You can do, for instance, string binding in here. So if I say string name let's say default stuff. We'll say DevWeek. There we go. What I can do here is I can actually go now back over to this edit text, and I could say Android. Ooh, it's very upset about something. Android text, and I could come in and say @string / what did I call it? Default stuff. There we go. So I could actually data bind that up, and if this is all working correctly, it should show up there. Let me try to clean this here. Oh, it's very upset about something. Oh, resource. What is that? So what happens when you try to change your demo all super late? Let's try this one more time. Oh, all right, let's try this. Resolve some namespaces. Ideally, built up. Weird that that didn't show up. All right, we'll see if it works. But we have our label in there. We have our button, and we can come back here and we can actually change stuff here. We'll say like get tweets. There we go. Perfect. So what's interesting here is we have these IDs. So you don't really name your controls. You give them IDs that you will then find in the code behind. So we have our UI in place, and in Android we have this thing called a main activity. So a main activity is like a UI view controller. It has all the the state for a single page of our application. And in Android, everything is very decoupled, and oh, I know what happened here. I want that to be there. Hold on one second, or else this demo is totally gonna fail. We don't want this. Change the namespace, that's so upset at me. Love it. This is a great point to show off how we integrate into each platform into the properties pane. We can see all the Android properties here, build properties that we have, advanced linkers. You can always define your own conditional compilation stuff in there. Pretty sure that should fix everything up. Yes. Let's try it again. Cool. Ugh. Oh, that's why. I added some namespaces. Now it's going to be all upset at me. Good thing I've been doing this for 4 years, right? All right, so this is a single page of our application. We can see I have my Twitter view model here. Now what we could do is we could say, let's go and find that button. We have to say find view by ID, and this is going to be a button here. Let's say resource.id.button1. There we go. So that was the name of that beautifully named button that I had there. We'll also find our search, and we'll say find view by ID, and this is going to be an edit text. So resource.id.edit text1. There we go. And then we're going to find our list view. In there, we'll say find view by ID, and this will be our list view. There we go. Resource.id.list view. This is kind of like almost kind of the tedious part of Android development is you think that you could just get the button dot one dot whatever, but it just doesn't work that way. Unfortunately, you have to go find the IDs. They did it this way so you could inflate an entire user interface, but they didn't have to actually generate all of those controls in the code behind for you automatically, so you do it manually. You only have to do it once. You can leave them all here, or you could actually dispose and do different things for you automatically. What we can do now is we can say button.click, and we can say plus equals, and we'll say sender args in here. There we go. And what we want to do in this instance is maybe we'll do button.enabled equals false, and then we'll say button.enabled equals true. There we go. And then, of course, we could await our view model. Oh, it's going to be upset because I didn't put async in here. There we go. Say view model dot load tweets, and we'll go ahead and pass in our search dot text. Of course, we'll be trim and be a good citizen there. There we go. And now we need to actually tell our list view, just so we did on iOS, how to actually go ahead and inflate things and actually display them. This is extremely tedious code to write, so I'm not going to do it again. I already have it created. We have this thing called an adapter. It's kind of like our data source. But what I'm doing here is I pass in my view model. I have a little get view where I actually go out, load the specific tweet control that I want to do, load up a photo, and actually set everything. Very similar to iOS. I just didn't want to have to rewrite it from scratch. But this is what it looks like. A little tweet has a little image, a name, a time, a tweet on there as well, which is kind of cool. And that's it. So what we're going to do at this point is we can say list view.adapter. We'll set that equal to a new tweet adapter. And we'll pass in our view model. There we go. And in fact, we could be a good citizen here, and we could put this up top. We don't want to create it over and over again. But what we can do here is we can ensure, we're going to be on the UI thread, but this call really, really likes to be on the UI thread with this call. And we'll say adapter, there we go, equals adapter. We'll simply say adapter.notify dataset changed inside of there, and we'll be good to go. Cool. This is a very special call on Android. It just really likes to be wrapped up in this call. So now I'll go ahead and set this Android startup project. Now, we have a lot of different ways of debugging. There's Google Android simulators, which are very slow and clunky. The x86 ones are a little bit better. We have our own Android emulator called the Xamarin Android Player. It's available for both Mac and PC. Now, this here is running on my Mac, so it's actually all right here. And this is gonna boot up and show really, really quickly how fast this puppy is comparatively. It's all based on VirtualBox, so it's using virtualization, acceleration with the GPU and everything. It's super fast and super speedy and whatnot. Now, I would do that inside of VM, but nested hyper-virtualization is no fun for anybody at all. So what I'm going to actually be doing here is running this on a real device, and I'm going to screen mirror it here with a little tool called MobiZen, which is really nice. It gives a one-to-one mapping. So here, for instance, I could add a breakpoint. We see that my physical devices or other emulators I have show up in this list. And if it compiles up, we should be able to get this running. It's doing some stuff. It's going to install the mono runtime for the very first time if we actually pull down here and see what it's doing. So it's going to install the mono runtime for the first time. This only happens if you're in debug mode. For release, everything is all linked up and compressed down really tiny. So we don't ship the entire mono runtime with your app, obviously. That would be extremely large, like 30 megs. We do it in debug build so we don't have to keep doing it and compiling it over and over again. For Android or iOS, we obviously have to ship some of the mono runtime. It's about 2 to 3 megs based on what you're using. So that is one implication when you develop with Xamarin, is that you add a little bit of size to your app. All right, so here we'll see this launch up here. It looks nice. We got DevWeek. Like I say, get tweets. I hit a breakpoint here, just like you would expect. I have my locals. I have my watch window, everything that you would expect inside of here. My sender was the text view that came in, which is button derives from text view. We can continue on. I didn't put any progress in there, so we're just going to assume the internet's working. That'll be good. And there we go. All my code and logic for pulling down tweets, doing everything for me automatically. And this thing is pretty butter smooth, and there's actually lag in that, but because of the screen mirroring. But that's pretty good screen mirroring lag. Like, that's native performance, what your users are expecting through their applications, which I think is pretty awesome. And all that code is there. I just added a little bit of user interface. So I think that's pretty cool, building out an application, sharing all that .NET code, everything I just kind of wrote once. But I talked a lot earlier about this approach, which is that shared C# backend. But I really didn't go too much into detail about what does it mean? What is this junk sitting up on top? What is that Android UI, iOS UI? Well, I showed you that already. But there's a little bit more in those colors than just that they're very pretty colors. You have the UI bits, which is I tied up to the backend. And then you have all of the platform-specific APIs. Things like GPS, text-to-speech, batteries, lights. Some are specific only to iOS and only to Android. So for instance, iOS has like AirPlay support, and then Android has like Chromecast support, and a few other interesting things. Same thing with Windows Phone. It has its own special different properties like NFC. But a lot of the APIs are exactly the same. Like getting a GPS, lights, notification, but they have a different API on iOS, a different API on Android, and a different API on Windows Phone. Like, wouldn't it be great if we could just write less code and share more code and didn't have to worry about all of those APIs? Well, just like we have the .NET library, we have Nuget, and we have PCLs, we can abstract all of these APIs into something that's platform specific. We can make a platform specific API for each of these, and we call those plugins for Xamarin. And this is a plethora of different plugins created by some employees at Xamarin, but also amazing community members that are all open source and are available on Nuget. And enable you to access these APIs, taking photos, text-to-speech, push notifications, device rotation, accelerometer, all from a single 1 or 2 lines of code from your shared code or your PCL code. You could also write that code only in an Android project, only in an iOS project. It doesn't matter. But you get a common API for all of these amazing functionalities. So let's do this. Let's extend our Twitter application here. So what I'm going to do is I'm going to come back over to this application and stop debugging. And at this point, I'm going to come up to my shared code. So I'm going to drop down the Android code here. I'm going to go into my Twitter view model. And I'm going to go ahead and I have a method here called speak. So I'm going to say when I tap on a tweet, let's read that back to us in real time. So what I'll do here is the very first thing I'd want to do is come up to manage Nuget packages. And we have a great hand curated list of Nuget packages. So when you go to github.com/Xamarin/plugins, there we go. There's a hand-curated list of all the plugins that are out there, so contacts, cryptography, file store, compression, everything. Links to the Nuget, links to the GitHub, links to the creator. You'll see my name quite a bit. That's what was on there. And if Nuget's going to work at all, let's see. Nuget, always super speedy. I feel like maybe if I close it and reopen it, that'll totally fix it. Because they haven't spun up like a whole bunch of threads in the background. What's that? The command line tool. It is, yeah. The nice thing is the Nuget package manager is completely open source, and anyone could fix this. They definitely did not fix it in Visual Studio 2015. No, they did not. If you've installed it, you're like, oh man, it just got like 1,000 times worse. Well, let's see. Perfect. Love it. Well, luckily, I already have all mine offline in cache, so you can see the ones that I created at least. But when you type plugin for Xamarin, you'll see all the different ones here. Now, I've already added the text-to-speech plugin that was created by me. I could always now go to the project information page. On all of these, all of the plugins are open source. We work with the community to make these all open source under MIT license, which is an App Store-friendly license. So here you can actually see all the source code that I have here, and if I go into text-to-speech here, I go through the whole API that I'm going to speak back some text, do volume, speak rate. You can set the language or locale. And I support Windows Phone, Phone RT, iOS, Android, all of Xamarin. And this is the API, cross-text-to-speech.current.speak. It's just that easy. I gave it a bunch of overrides here as well that you could pass in optionally. And what I'm doing under the hood, so you don't have to worry about it, if I look at, let's say, Android, and go into the text-to-speech implementation that'll get called, it's like all this nasty code to like pull into the system's TTS service, actually play back text and actually speak it, and there's different lollipop APIs. It's like a bunch of code that you don't have to write. So let's go ahead and implement this here. So here I'm going to come over to here, and I'll say, I want to go ahead and do, let's go ahead and speak back our tweet.text. There we go. And we could spruce this up a little bit, and we could say at C plus tweet dot date, put a space in there, tweet dot, see here, screen name, tweeted. There we go, nice and long. So it's going to figure out all that for us automatically. Now this is in the shared code. So of course I need to call into that some way from, let's say, Android. So I'll come back into my main activity. I'll say listview.itemClick. So whenever we come in here, we'll send our args. And what we can do now is we can come in and say viewModel.speak. And I'm calling this from my Android project, and I'm doing this way, so my shared code is handling what I want to actually change. So if I change it, it automatically updates on Windows Phone or Android or iOS. And I'm going to speak back my args.position, pass in the current index. Now if I run this again, over here, this will actually speak back some text. And how this is working under the hood is I have the same package installed in all my projects. And what you can think of is that in the shared code, there's no implementation. It's just a contract, an interface that I'm coding against. And then at runtime, it goes down into the native libraries for me. So let's go ahead and say get tweets. Let's see if is there one about my session? There we go, that one looks good. So I tap it. Ideally, if Google wants to work with me. Oh.
Hashtag Xamarin demo at hashtag DevWeek now. Should have another look at it. It's been some time ago.
There we go. Let's do it again. Let's do this one.
At March 25th, 2015, 10:18 a.m. Incredible tweeted looking forward to another great day at DevWeek #DevWeek 2015.
My favorite is ones with URLs and how it speaks it back. Let's see if I can find one. So here's a good one.
At March 25th, 2015, 10:40 a.m. Nigel Tech Freight tweeted RT at Paulo, come and say hi at morning tea at Plankitronics session at DevWeek #DevWeek #Azure http://t.co/3j6view.
Perfect. And there's view. I loved it. Yeah. So with one line of code, I'm able to do that. I could bring it over to my iOS application. Additionally, what I have here is I have a full Windows Phone project as well. So actually, all this is already implemented. So, I have it working. It's a good question. Ooh. So what happens when I change all my namespaces? Ideally, this is going to work. I know on the GitHub, it's all finished. I'm not sure why that's not there. That is why. Change my namespaces correctly. There we go. So I brought in that same portable class library, all that other code. It's going to be super upset at me. What is going on? Localized strings. It may not like me 100%, I'm assuming. I might have changed a few too many things in this project. But rest assured, all the code is online and totally compiles and works. That's what happens. Classic Windows Phone every time. Oh, wow. It's too upset at me. But trust me, it just works, and the whole thing also is there as well. So that's kind of getting code, getting up and running. I want to talk a little bit about Xamarin Forms. I'm not really going to have enough time to kind of go through and demo it. It's a whole additional session, to be honest, because you can spend forever on it. So what we did is, a lot of developers said, it's amazing that I can take advantage of not only all of the APIs in the platform, create and craft a beautiful user interface, take advantage of all the animations and all these amazing libraries that are out there for crafting beautiful user interfaces. But what if I'm making like enterprise applications? I'm doing a lot of forms over data. So for instance, I'm pulling a database in, just loading some information, I'm editing it and pushing it back to a server. It gets really tedious to create the same screen over and over again. So what we developed was a new library that sits on top of Xamarin called Xamarin Forms. It's just a Nuget package you bring in. But it enables you to build out a shared user interface across iOS, Android, and Windows Phone. So the easiest representation I can say about this is that I said in my shared code, new map, in Xamarin Forms displayed and rendered the native Apple map, Google map, or Bing map for me automatically. I didn't have to do it under the hood. So you think here we have our traditional native approach, take advantage of everything. Xamarin Forms just adds to that equation. All that business logic, the models, the view models, are 100% still shared. Then we add a new layer that just brings down our actual platform-specific user interface code. You can still create your own custom controls and implement them, but it's a shared UI layer. And we still enable you to get to the actual iOS, Android, or Windows native APIs. So included out of the box is like 40 different pages, layouts, and controls. Build them in C# or in XAML. It was XAML, it's our XAML, but we did include two-way data binding, a navigation paradigm, animation, dependency service, and a messaging center. So it's kind of like an MVVM framework, plus also the UI toolkit as well, which is really cool. There's a bunch of pages like a navigation page, tabs, a scroll view, master detail view, which actually it pulls out like a little bar there with like a little hamburger button. And then we also have layout. So we gave you a common layout engine across all these different platforms, so like a stack layout, an absolute layout, relative. And you can mix and match all these together, all in shared code. And then of course the controls. So there's a whole bunch of different controls. You can always bring in your own control, but it's not every control. It's kind of what's common across the platform. So it is an abstraction. So it's a layer of abstraction on top of these platforms in general. We have a great ecosystem of control vendors that already have controls for Xamarin iOS and Android, and they created a common library for Xamarin Forms. Some of those names should look familiar. So this is kind of what it looks like under the hood. You have some XAML. So here I'm creating a tabs page, and the first page here is a stack layout with some entry labels and a button that I'm going to click to log in. And I just have common data binding to username, and it just renders correctly on iOS, Android, and Windows Phone. It's all XAML. Yeah, it's all XAML. And these slides are all available to you guys as well if you can't see it because it's a little bit smaller. So it's a single API to do all that. So it's all XAML with triggers, behaviors, things that you would expect. It's built against a newer spec than what Microsoft uses. We use the 2009 spec, so we can do some really cool things in it. But if you know XAML, this will get you up and running fast. Now, of course, there's some considerations. It sounds like, oh my goodness, James, why didn't you just demo this? It seems like the silver bullet. Because it's not the silver bullet. It's not for every single application. I wouldn't expect like Rdio or Spotify or some other like Google Music to actually use something like this that needs every single custom control that they're doing and tie into all the different APIs, make this craft beautiful user experience and stream music and download all this cache. That's really platform specific, traditional native Xamarin approach. If you're doing forms over data, CRUD operations, or if you're proof of concepting, fantastic. All of my libraries that I create, I just create a little Xamarin Forms, test it really quick. That way I don't have to build out a separate application each time, which is really good. Great for POCing and just prototyping in general if you want to play around with a few different things that you're creating. So that's Xamarin Forms. Don't have enough time to see how it looks, but sure enough, when you go to my GitHub page, there's going to be tons of examples you can pull in and download in general. The entire tweet application is all available on my GitHub. It's github.com/JamesMontemagno. You can find me everywhere on the internet. All the slides are on my SlideShare already, but they're also available in the DevWeek. Plugins for Xamarin are there, the component store, and link to Twitter, which is an open source project, which is very cool. I do have a few more minutes, so I want to say if you want to get started, Xamarin.com, full 30-day trial. We have multiple tiered subscriptions, so it's a year-long subscription to Xamarin. We have a starter free edition, which is for very small applications that does not work with Xamarin Forms. We have indie, professional, or business, and then enterprise. You can see all the different levels that are there and what they include. And some are monthly, and most of them are just yearly subscriptions to do that. And I want to thank everyone so much. Have an amazing Dev Week. And if you have any questions, I'll open it up to that. Yeah, thank you. Any questions?
I have a question about unit tests. Could you tell us something about how easy it is to do? Is similar to the usual Windows code, and if this can be run just on the PC, or it needs to be on the simulator?
No, so for unit testing, the question was all about unit testing. How does that work with Xamarin? So there's popular frameworks that are compatible with Xamarin, NUnit, XUnit, MS Test. They're all compatible with Xamarin iOS and Android projects. It's just really, you're going to be testing your business logic parts of it. So you just create your tests. Additionally, what we have for iOS and Android is a test runner application. So obviously you're running your unit tests just kind of in your own Visual Studio or Xamarin Studio test runner. And that's great because you're just testing to make sure that you're past your asserts. But that doesn't necessarily mean that code is going to run on a physical device. Because let's say on iOS, it's fully ahead of time compiled, which means you can't dynamically emit code. It just doesn't work. It's a limitation of how iOS works. So we have a test runner script, or a project, that you just include your unit tests. And for each unit test, it creates a little runnable application in a list view. And you say run all, and then it'll run it on a simulator, which would actually be able to dynamically emit code, or on a physical device. So you can actually run all of your tests and see them running on a physical device, see if they're running or testing. So it's very simple to get up and running doing that. And then you could extend that to UI testing with UI tests, and it's all C#, just really cool. Mm-hmm.
Okay, you can talk about mobile development, obviously, but this all applies to OS 10 on that. You can write stuff for.
Yeah, totally. Yeah, so for instance here inside of Xamarin Studio, we have full support. I'm not a Xamarin Mac guy too much. Our other evangelist here that's local to London, Mike James, he's a Mac guy. So, but you can come in here and there's a Mac application, and we can see I could create a Mac app, I guess. Let's see, test Mac. There we go. See if this works. The intricate part of the Mac application is that there is no Storyboard Designer for it. There's all nibs and things here. So for instance, one intricate part, if you are an iOS developer, is you can always open everything in the Xcode interface builder. So this is how it was traditionally done for iOS applications before. So for here, you would just kind of drag out controls, like here's a button, that's cool, and you save it. And then when you come back down, Xamarin Studio syncs automatically with Xcode. But then, of course, you could use all your portable class libraries, your shared code between Mac, iOS, Android, Windows, doesn't matter. Yeah, that's how it works. Very simple. Anyone else? Well, awesome having him. Yeah. Oh.
Very quickly, you did the mirroring with your Android device. Can you do a similar thing on iOS?
So you can. So I have a whole blog post on my blog. When you go to Mott's Codes, it's my most popular blog post. When you go to motts.codes, that's it. I also have business cards if you want. That's an even fancier URL that just redirects to my ES. That's a physical domain. It's not that expensive, $30 a year, totally worth it. So on there, if you just type James Montemagno screen mirroring, I use multiple applications called Reflector, also built into QuickTime on the Mac, is a way to actually just reflect backwards. But I have a blog post that goes over Android, iOS, and Windows Phone screen mirroring. As an evangelist, after 150 presentations in a year, you kind of learn how to do it very well. Yeah. So. Well, awesome having. Yeah. One more question. You guys, yeah.
Is there any limitation on the editions of Visual Studio you can use? It works across.
Oh, so it works all the way back to 2010. But of course, I don't recommend using 2010 because there's no .NET 4.5 support. So you wouldn't get Async Await and things like that, which is kind of not great, especially for a lot of the new libraries that are coming out. So 2012, 2013, 2015 are already supported. The only limitation is you cannot use you can use the new community edition, which works fine. You can't use their old starter edition, that was whatever it was called. It didn't allow extensions. Express, you can't use Express. Correct, so that was the only issue. You couldn't use that. But now with the community edition, you can use that, and we have full support for 2015. I don't demo in 2015 because it's pretty crashy. Not us, well, us and Visual Studio, I would say. But we're usually out, we sim ship Visual Studio releases. We have a great relationship with Microsoft and work with them extremely intensely. Any other questions? Cool, awesome. Have an amazing Dev Week, and thank you guys so much. If you have any questions, feel free to contact me. I have stickers as well, if you guys want to grab some stickers. And my business cards, because who doesn't want some Xamarin stickers?